Minerals, which is Unit 7, Lesson 5. Here are vocab words for today. Mineral, luster, streak, hardness, conductivity, malleability, magnetic attraction, inorganic, mineral crystal, and Mohs hardness scale. Our first word is mineral, a naturally formed inorganic solid that has a specific chemical formula and repeating three-dimensional structure. So this just means that the chemical formula differs or is different for each mineral. And we talked about chemical formulas. It tells us what elements and how many atoms of each element are in the structure or in the chemical. And a repeating three-dimensional structure. So that means the elements are arranged in a way to where it's the same all the way throughout the material. Here's an example of a mineral. So today we're going to talk about several different characteristics of minerals that we can test. The first one is luster. We talked about this back in our chemistry unit. It's the way the surface of a mineral reflects light, either metallic, which means sparkly, or non-metallic, such as silky, dull, etc. So here's an example of luster. You would say that this diamond or this gemstone is very shiny. Our next physical property of minerals that we're going to test is called streak. And this is the color of a mineral in powdered form. So what you do, you take a piece of porcelain, it's like a tile, like you might put in your bathroom or your kitchen, and you take the mineral and you scratch it across the surface. And if it leaves a line, then you look at the color. And the cool thing about streak is that the mineral could look one color and the streak could be completely different. So a lot of minerals, they may be gray and they might leave a black streak, or they might be like a red color and their streak is brown. So the streak color, this line here, has nothing to do with the color of the actual mineral. They could be completely different colors. So here, for example, we have this kind of like black mineral. It leaves kind of a reddish black streak. We have this one that looks kind of gray, but its streak is brown. So again, just because the mineral looks one color, the streak could be something completely different. Hardness is our next physical property. It's a measure of scratch resistance of various minerals. It's the ability to scratch is used for identification. So you take one mineral and you scratch it against a substance like a penny or a nail, or you can take one mineral and scratch it against another mineral. And whichever mineral is harder will be the one that does the scratching. So if you take a piece of like pyrite, which is a mineral, it's like fool's gold, and you scratch it against a piece of glass, if the mineral scratches the glass, then the mineral is harder because it scratched the glass. If the mineral does not scratch the glass, then the mineral is softer than the glass. And so we can use hardness to kind of narrow it down for what mineral we might have. So see, for example, I believe this is a piece of quartz, and they scratched it against a piece of glass, and the glass did scratch. So this quartz, I believe, is harder than the glass. Our next property is conductivity, and you should already be familiar with this one. It's a property that describes if heat or electrical charges pass through the material easily. So if we hook up a battery and a light bulb and the circuit is complete when we put the mineral in the middle, then it is conductive. So it will allow heat or electricity. If we put the mineral here in the middle and it doesn't light up the light bulb, then it is not conductive. And that can help us narrow down what mineral we might have. So again, here's just a little bit fancier picture of that same idea. If the circuit is allowed to continue, then whatever mineral we put in the circuit is conductive. Our next word is malleability. And again, we've had this in a previous unit. It's a property that describes the ability of the material to be rolled or hammered into sheets. So if we can hammer it and it doesn't break or rip or tear, then it is malleable. So this one is malleable because it can be bent and not get broken. Magnetic attraction, again, this one you should be familiar with. It's magnetic force exerted by oppositely charged particles tending to draw or hold particles together. So if it gets attracted to a magnet, it's magnetic, and if it doesn't, it's not. That one's pretty self-explanatory. So obviously these nails are magnetic. Next is inorganic. So this might be a new word for you. This doesn't mean that, you don't pay extra for it at the grocery store. It's not what that means. It just means all matter, that does not have the chemical and structural characteristics of living matter. So in a mineral or in a rock, all of the material has to be inorganic. So that means nothing in the rock should be living, or the mineral. So it's all non-living matter. So for example, these rocks are all made of inorganic or matter that is not alive. Mineral crystal. So this is the geometric shape of a mineral that reflects its internal crystalline arrangement of atoms. So basically whatever form the mineral kind of takes when you look at it, that's kind of how the atoms are arranged inside of the mineral. So if the mineral looks square, then the atoms are probably arranged in a square shape. Or if the mineral is like diamond shaped, then the atoms probably have a diamond shaped structure. So usually the shape of the mineral reflects or similar to the arrangement of the atoms. And again, you can kind of look at these different minerals that are in here and see how they're all kind of in different shapes. And then lastly, we have Mohs hardness scale. So this is kind of what I was talking about with the glass and the quartz. So it's a set of 10 minerals used as a standard of hardness against which an unknown mineral's hardness is compared. So again, we would take our mineral that we have and we're trying to figure out what it is. We would scratch it against different substances. And if it scratched the substance, then we know it's higher on the scale than what it scratched. If it doesn't scratch the other substance, then it's lower. Okay. So I believe glass is about a 5, 5.5. So if we have a substance and it scratches glass, then it's going to be higher. It's going to be up here on the higher end of the scale. But if we scratch the glass and it doesn't get scratched, then it's going to be on the lower end of the scale. So for example, a 1 is talc. So talc is kind of like baby powder. It's so soft that almost anything can scratch it, even your fingernail. Quartz again here is a 7. So that would explain why the quartz in the previous picture scratched the glass, because the glass is about a 5, 5.5. So since quartz is a 7, it would scratch something that has a lower number. Okay. And then always number 10 is a diamond. The only thing that can scratch a diamond is another diamond. And a diamond can scratch anything. So a diamond would even scratch this number 9. Even though this number 9 is very hard and would be able to scratch almost anything, it cannot scratch the diamond because the diamond is a 10 while it's only a 9. Okay, so we're going to be discovering minerals. So rocks are made of minerals. The definition of a rock is basically various minerals that are together in one substance. Minerals occur naturally in the lithosphere. So when we go and mine these minerals or we dig them up, that's always in the lithosphere or the crust. Minerals are solid, inorganic substances that occur naturally in the topmost layer of the earth. So these are always solids. They're inorganic, so they're not made of living materials, and they are found on the top of the earth. So again, luster is the way its surface reflects light, sometimes referred to as shine. There's metallic, which is shiny and reflects. So if it's shiny, if it's sparkly, it's called metallic. If it's non-metallic, then it's going to be dull. Like we talked about in the chemistry unit, not all substances have a luster. If you have a gas, that's not going to have a luster because you can't see it. Other terms about luster can be resinous. So this is going to look like it's kind of sticky, waxy, pearly. So this might be kind of shiny and swirly, glassy, or shiny. Those are some of the ones you might hear. So color is easily identified by viewing. You just look at the material or the mineral and you say this mineral is black or this mineral is green. You know, it's just that easy. Color, you just look at it and you say what color it is. Sometimes they may be, like in the case of pyrite, it's black, but it has gold kind of bits in it. So you would want to say black and gold. Hardness is determined by comparing it to the Mohs hardness scale. So again, you would scratch it against stuff and see how it fell on that 1 to 10 scale. The streak is the color of its crushed powder. Fracture, this is one we haven't talked about yet. This is the way a mineral breaks. So when we hit it with a hammer, does it look very crumbly and uneven, or does it break on a straight line? Acid test, you might put some acid on the mineral and kind of see, like, does it have any reaction? Does it bubble up? Does it have, blue bubbles or clear or white bubbles? Kind of what happens when you put acid on it. Cleavage is very closely related to fracture. So it's how likely the mineral is to split on a structural plane, which just means if you hit it or if you break it, is it going to break flat? And if so, does it always break like horizontally flat or vertically flat? We'll look at some examples of cleavage in class, because it's a little bit harder to kind of understand cleavage. All right, now we're going to go ahead and talk about Mohs hardness scale a little bit more. So in 1812, a German geologist named and mineralist named Friedrich Mohs created a method of comparing the hardness of minerals' hardness. Okay, so he was comparing how hard the different minerals were. So to test a streak color, you rub the mineral on an unglazed piece of ceramic tile, a streak plate. If it has no streak, it means it's white or colorless. And so you're going to scratch it on a porcelain plate and see what color it gets left behind. The hardness scale is a relative scale, meaning a mineral will scratch any substance lower on the scale and will be scratched by any substance higher on the scale. So if you're like a 5, you're going to scratch anything from a 1 to 4, and you're going to be scratched by anything from a 6 to 10. So anything lower than you can beat up, and anything higher than you will beat you up. Okay? So it's kind of the same with middle school. Anybody lower than you can take care of, but anybody bigger than you got to watch out for. So here we have our example minerals. These are always going to be the same in our hardness. So again, talc is very soft, diamond is very hard, and in between we have different ones. Topaz is a very popular gemstone that you might see in jewelry. It's an 8, so it will scratch everything from talc to quartz, but corundum and diamond will scratch it. So these are the kids that are bigger than topaz, and these are all the kids that are smaller than topaz. So geologists use the scale to test the relative hardness, and it is not absolute, which means it is not always a perfect indicator of what mineral you have. So if you're going to test minerals to find out what mineral you have, if you're not sure of what mineral it is, this is not the only test you should ever use. You should always do multiple tests to make sure that you're choosing the right mineral.